EES, which is pronounced ease, is an acronym for Engineering Equation Solver. We have seen that there are a variety of property models that can be used in ease to obtain the properties of fluids. So these include real fluids, ideal gases, incompressibles, and brines. The exact protocol for obtaining the properties of these different types of fluids is not the same, and therefore it may be difficult to switch between, for example, an ideal gas and a real fluid within an ease model. The FluidType function makes it possible to automatically detect the type of fluid model that's being used and therefore adjust the ease code accordingly. The FluidType function accepts as its only argument the name of the substance. If the substance is any built-in ideal gas or ideal gas from the NASA database, then the function will return the string ideal. If the fluid is one of the built-in real fluids, then the function returns the string real. If the name is recognized by the incompressible substance library, then the function returns the string incompressible. And finally, if the fluid is a brine, which is a mixture of water and another substance, then it returns the string brine. The FluidType function is particularly useful if you are developing a function or a procedure that takes the fluid name as an input and must work properly regardless of what type of fluid is provided. So for example, let's write a function to determine the outlet temperature of a turbine given its isentropic efficiency. Functions are discussed in section 3.2 of Mastering Ease, and the inputs to this function include the fluid name in the string $, as well as the input temperature and pressure, Tn and Pn, the outlet pressure, Pout, and the isentropic efficiency of the turbine, eta. We would like this function to work if it is called with either an ideal gas or a real fluid, but we don't expect it to work with either a brine or an incompressible substance. Therefore, our first step is going to be to check if the fluid name contained in the string $, is a brine or an incompressible substance, and, if it is, call the error procedure, which will terminate the execution of the ease program. The error procedure is discussed in section 3.9 of Mastering Ease. The inlet state is fixed by the inlet temperature and pressure. The inlet specific entropy is determined using the entropy function. Note that the specific entropy is a function of temperature and pressure regardless of whether the fluid is an ideal gas or a real fluid. The inlet specific enthalpy is determined using the enthalpy function. Note that the enthalpy function must be called using only temperature if the fluid provided by the string $, is an ideal gas. Otherwise, enthalpy is a function of both temperature and pressure if the fluid is a real fluid. This logic is accomplished easily using the FluidType function coupled with an if-then-else construct. The specific enthalpy at the outlet state for a reversible turbine is obtained from the outlet pressure and the inlet specific entropy using the enthalpy function. And note that both pressure and specific entropy are required in order to determine temperature, and as a result both inputs are going to be required regardless of whether the fluid is a real fluid or an ideal gas. The outlet specific enthalpy of the actual turbine is computed using this equation, which takes into account the efficiency of the turbine. The outlet state is fixed by the outlet enthalpy and the outlet pressure. Specific enthalpy is only a function of temperature for an ideal gas, and therefore the converse must be true. Temperature must only be a function of specific enthalpy for an ideal gas. If the fluid is an ideal gas, then the outlet temperature is obtained using the temperature function only with specific enthalpy. Otherwise, the temperature function must be called with both specific enthalpy and pressure, and that's accomplished again using the FluidType function. So with this, then the function turbine will work when it is called with either an ideal gas, so for example air, or a real fluid, so air underscore HA. If the function is called with either a brine, so for example ethylene glycol, EG, or an incompressible, so glycerin for example, then you're going to get an error. So this is one of a series of tutorials meant to describe the operation of the ease software. If you'd like to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from the FChart website.